For section 10.4, we're going to be adding and subtracting radicals. Basically, it's like adding like terms. So when I see 3 root 5 plus root 5, people go, oh my goodness, that's all craziness. And I go, wait a sec, can you do 3x plus x? 3 of something plus 1 more of something makes what? 4 of those things. We've done this with x's. This is basically like a variable. We're adding root 5s. If I have 3 of them plus 1 more, I end up with 4. 4 what? Does the x change? So if the x doesn't change, the root 5 doesn't change. Now be careful, because the only time we can add is if they are the same, if they're both root 5s. So just like we can't add x plus y, this is already simplified. So it would be for root 5 plus root 7. Those are not like terms. They have to be the same radical, the same term, to add. So if I asked you to simplify 3 root 24 plus root 54, you'd look at that and go, well, that's easy deal, already simplified. Well, you do need to actually verify, because the square root of 24 itself can be simplified. 24 is 4 times 6. The 4 splits into 2 and 2. The 6 into 3 and 2. Since I'm doing a square root, remember square root means we're looking for groups of 2. There's an implied 2 there. There are 2 2's. So those come out, because this is all under a square root, okay? And the square root of 4, out comes that 2. Don't forget the 3 is out there. Do not make those 5. Right here, this is not 3 plus, this is 3 times. So the 3 times 2 becomes 6. Left in the radical is the square root of 6. Square root of 54, I'm thinking 9 times 6. About 3 times 3 times 3 times 2. Looking for groups of 2. That is the square of 9. So out comes a 3. And what's left in there is radical 6. Can I add 6 radical 6 plus 3 radical 6? They are like terms. 6x plus 3x, 9, whatever the x is, the variable, okay, 9 messes. Things are going to get a little trickier. Here I have to simplify this. Well, 20 is 4 times 5. The 4 can be brought out, or if you're not sure, split it down. I recommend bringing everything down every time. So what comes out is a 2. 2 comes out, hits the other 2. We have a 4. But I also have x squared. So that means x, or x to the third, sorry. So that means if I have 3 x's, I'm pulling out 2. 1 comes out, and I'm left with 1 on the inside. So that would be a 5 and an x. What I did again was 3 over 2. 1 comes out, with 1 remaining inside. If you don't like that, draw out the 3 x's, circle one group that comes out, and 1 x is left inside. This next one now minus 45x, there's already an x there. So, I guess I won't mess with that yet. 45, 9 times 5. About 3 times 3 times 5. 3's come out. And so that leaves us with 3x square root of 5, and that x is stuck in there. Are these like terms? Well, are the radicals the same? If they are, then we can add the coefficients. We can add this in the front. So 4x minus 3x is just x square root of 5x. Another way of thinking about this is that these both have this root 5x in common. So it's almost like thinking we could factor out. And if I pull that out from both of them, I'm left with 4x minus 3x. Excuse me, which is x. And so it's just x times a square root of 5x. Two root 11, 4 root 11, 3 root 44. I already see 2 like terms. Is this another one? Probably. Let's see. 44 is 4 times 11. 2 times 2 times 11. Out comes a 2. So really, let's see. 2 minus 4 would be negative 2 square root of 11. And this becomes plus 3 times 2 is 6 square root of 11. Negative 2 plus 6. How about 4 square root of 11? Okay. This will also work for higher roots. So here I have a third root. Remember, for us to add it, they must be the same terms inside the radical, and they must be the same root. So these are both third root. That's important. I would not add. These do not add. Okay. This is already simplified. Alright, so with that in mind, 81, 9 times 9, how about 4 3s? Well, what's coming out this time? Well, we're looking for groups of 3. So there were 3 3s. Out comes a 3. 7 times 3, how about 21? Third root of 3 plus 24, about 4 times 6, 2 times 2 times 2 times 3, group of 3. Out comes a 2. 3 times 2 is 6. Third root of 3. 21 plus 6. Add the like terms. 27. Third root of 3. Looking for groups of 3. I have p to the 4 thirds. 1p comes out with 1 remaining. Q to the 7 thirds. 2 come out with 1 remaining. Minus third root, 64 is 8 and 8. 8 is 3 2s. 8 is 3 2s. So 2 times 2, out comes a 4. So 4, third root of PQ. I wouldn't go any further with this, but what they'll do is they'll go, well, look. These are the same. So they're like, so you could add PQ squared minus 4. You're like, that doesn't really add to make anything. I agree. What the homework will want you to do, though, is think about factoring out that third root of PQ. It's a Q, I promise. And going, well, what would be left? PQ squared minus 4. Or third root of PQ times PQ squared minus 4. I don't really know how that's simplified, but they will do that. That's not something I would test you on, but I don't want you to get frustrated when that shows up in the homework. Okay. Fractions, we've done this before. To the side, I'm going to do the square root of 75. Remember, we're going to split this. So the square root of 75, about 25 times 3, 5 times 5 times 3, out comes a 5. So we're left with 2 times 5, how about 10, square root of 3, over square root of 16. On the denominator, out comes a 4. We should probably simplify that. 10 over 4, about 5 over 2. Plus, square root of 8. Well, 8 is 2 times 2 times 2. Out comes a 2. 4 times 2, 8. Square root of 2 over square root of 32. 8 times 4, 8 is 2 times 2 times 2. 4 is 2 times 2. Looking for groups of 2. So out comes the denominator of 4, and we're left with a square root of 2. 8 and 4, divisible by 4, that becomes a 2. We got a square root of 2 and a square root of 2. Those can also cancel out. So really all we're left with is 5 root 3 over 2 plus 2. And that is simplified, basically. We have simplified something that was, we were able to kind of just simplify it. We couldn't really add them together, but we can still simplify that. So that is it for this section. Not terribly complicated. Just go ahead and work through it, and we only have a few more sections left for this chapter, so let's finish up strong.